Hello everyone. In today's video we are discussing about finite state machine in automata theory. So finite state machine is nothing but it consists of a finite automata. So we can solve with output and without output. So Moore machine and Milli machine will solve with output, and finite automata without output we can solve by DFA, that is deterministic finite automata, NFA, that is non-deterministic finite automata, and epsilon NFA, that is empty non-deterministic finite automata. So let me tell you about the finite automata. So here finite automata is an abstract computing device. It is a mathematical model of a system with discrete inputs, output, state and set of transition from one state to another state to access an input symbol from alphabet. Okay, and we know that we are having some mathematical model, some state diagram we will be solving, and that will be having some input symbol, output states, input state and some transition table, and how we are having states, so it will move to one state to another. So here a finite automata is a 5 tuples, that is M is nothing but machine will contains Q, sigma, Q naught, F, delta. So here capital Q is a finite set of called states and sigma equals to input or a finite set called alphabets. Q naught, that is from capital Q itself, that will be a start state, and final state we will get from capital Q itself, that is a accepting state, and delta is a transition of total inputs and number of states, so that we will get a transition function. So we'll discuss about DFA and we will solve DFA problems. So here deterministic finite automata is a DFA or a DFSM. The finite automata are called deterministic finite automata if machine is reading an input one symbol at a time. So deterministic refers to uniqueness of a computation. In DFA there is only one path for specific input from current state to the next state. So we can have only one path, and this is a start state symbol with an arrow mark, and double circle when we are doing, that is a final state or a accepting state. So DFA does not accept null move, that is DFA cannot change state without any input. So here if I don't have any input, it won't change to B state. Okay, so DFA can contain multiple final state. It is used in lexical analysis in a compiler. And definition of a DFA is collection of a 5 tuples. It is same as a finite automata C. And machine equals to Q, sigma, Q naught, F, delta. So Q equals to finite set of states, finite set of input symbol, start state or initial state, and final state. So Q equals to transition function. So we'll discuss problem in the next videos.